G'day ladies and gentlemen, today we'll be dealing with operations related to uncertainties. Say if you're doing a scientific experiment and you have multiple values and those values have different uncertainties and you need to perform an operation on those values, of those values onto each other, what would you do? So let's get into it. So if you add values that have uncertainties, you add those values as normal, and then you add the uncertainties, as an example here. Similarly, if you were to subtract values of uncertainties, you would subtract as normal, however, you would add the uncertainties in that operation as well. Now, if you were to multiply a value with an uncertainty by 2, such as in this case, any constant that is multiplied by a value of an uncertainty gets multiplied. So in this case, 2 would get multiplied by the value and by the uncertainty. And this is done because if you multiply something by a constant, it would retain the same percentage value that 0.3 has in 5.1 if you to multiply both values together. So the percentage 0.6 has in 10.2 would be exactly the same as the percentage 0.3 has in 5.1. If you multiply or divide uncertainties, you first have to always calculate the percentage that uncertainty has on that initial value, and then when you perform the multiplication or the division, you always add the percentage values together. So in this case, we have this value and this uncertainty, and this value and this uncertainty. We figure out that the percentage value 0.1 has in 1.1 is 9.1%, and 0.3 in 2.3 is 13%. And then when you perform the operation where 1.1 multiplies by 2.3, you would add the percentage uncertainties. You notice how I've rounded off this value and made it 2.5 plus or minus 0.6 after I calculated it, what percentage the uncertainty was of 2.53. Well, that's because there are two rules to uncertainties. First rule, uncertainties must have one significant digit. And second rule, the last decimal place of a measurement, 2.5 in this case, must be the same as the decimal place of the uncertainty, 0.6 in this case. And finally, if you were to perform a square of an uncertainty, say you went 1.1 plus or minus 9.1%, you would perform the square operation on 1.1, so that would be 1.21, but then you would multiply that uncertainty by 2. If you were to cube a value of an uncertainty, you would perform that operation 1.1 cubed, but then you would multiply that uncertainty by 3, so on and so forth. Now finally, if you were to square root an uncertainty, you would square root that value, and then you would divide that uncertainty by 2, because the square root is a half, power of a half. And similarly, if you were to cube root that value of the uncertainty, you would perform that operation 1.1, but then you would divide 9.1 by 3, and so on and so forth. Now I have another video coming up after this where I will utilize a real world type of example where I will demonstrate these processes, as well as calculating averages of multiple measurements and the average uncertainties. Please check that video out as well. Thank you.